hate to interrupt you because you're doing a great job of explaining it to them, but let's take a look and see how we're doing here. So 7 5/6 plus 2 3/8. We need to find a common denominator. What's it going to be? 24. Good. So what's this going to become? It was 6 times what to make 24? 6 times 4. So the 5 has to be multiplied by 4 as well. So that becomes 20. And then 8 times 3 makes 24. So 3 times 3 is 9. So 20 and 9 is 29 24s, which is 1 and 5 24s. So we keep the 5 24s, we carry the 1. 1 and 7 is 8, plus 2 is 10. So 10 and 5 24s for the first one. Any questions there? Now the second one we're going to have to borrow. Subtracting. First we got to find common denominator, which is going to be 15. This is going to become 5. Yeah. 3 times 5 to make 15, so 1 times 5 to make 5. This is going to be 5 times 3 makes 15, so 4 times 3 makes 12. So now we go to subtract. 5 minus 12 cannot be done. So we're going to borrow. That's going to be a 7. What do we have to do to the 5? Add 15. We add the denominator. So it's 20 15ths. 20 minus 12 is 8 15ths. 7 minus 5 is 2. So it's 2 and 8 15ths. Any questions so far? Okay. Next. 3 1/4 times 5 3/5. 3 times 4 is 12, plus 1 is 13/4. Now remember, we showed you yesterday that you could multiply these out, but it's much easier to turn them into improper fractions. So now 5 times 5 is 25, plus 3 is 28 fifths. Now we could just multiply straight across, but before we do that here, we can do what? We can cross cancel. Yep, we can reduce the 4 and the 28. Both divide by 4 to give me 4 divided by 4 is 1. 28 divided by 4 is, careful, 7. 13 times 7 is 91. 1 times 5 is 5. 91 divided by 5. 5 goes into 9 once. There's 4 left over. Bring down the 1. 5 goes into 40 18 times. That's 40, so there's 1/5 left over. So 18 and 1/5. Any questions there? For division, our first step is just like multiplication. We're going to turn them into improper fractions. So 7 2/3 becomes how many thirds? 23. Good. 7 times 3 is 21, plus 2 is 23. 1 1/5 will become how many fifths? 6. Good. Can we cross cancel the 3 and the 6? Say no. Why not? Right now it's still division. If it were multiplication, we could cross cancel, but it's still division yet. We are going to make it into multiplication. Exactly. Now the first fraction never changes. It's always the one that comes after the operation that's affected. So it's going to be times 5/6 instead of divided by 6/5. Now we could cross cancel, but unfortunately now there's nothing that will cancel. 23 times 5 is 115. 3 times 6 is 18. 18 goes into 115. 6 times 18 is 108. There's 7 left over. 6 and 7/18. What do you think?
Not too bad.
Now, you guys, see you've got your calculator out. Do you have one with you?
I keep forgetting to bring it. I
Okay.
just use my phone for simple calculations, but I plan on bringing my calculator.
Okay, let's take. So you've got that ABC key. Looks like that. That is our fraction key. So for this one here, to enter 7 and 5/6 plus 2 and 3/8. Go ahead and follow along with me. You're going to enter 7, then ABC, then 5, then ABC, then 6. Now plus 2, ABC 3, ABC 8. Hit equals 10 and 5/24. There it is. So the same for this one. 8 and 1/3. Minus 5 and 4/5. Now, if you hit the wrong key, you can always use your arrow on that little round pad up there to arrow back and type over it. Did you get the 2 and 8/15? Perfect. Now, let's say I just give you, you can do the same with the multiplication and division. Just type them in just as you see them, and they'll work out. Let's say I give you 12 40-seconds. So you say 12 ABC 42. And it gives you, what, 3/14? And hit equals. Or 4/14. 2/7. Okay, yeah, they're both divisible by 6. Yeah, 2/7 works. I could go one more spot. So it reduces them 42. Or if I give you 57 over 16. 4 and 9/16, or 3 and 9/16. So automatically break those down for you. Which is a good thing, because, so let's say I've got a 24 NF, right? NF stands for National Fine. 24 means 24 threads per inch. So if I take a nut, here's my bolt. If I take a nut, so nuts are 6-sided, not 8. If I take a nut and I turn it 1 turn, how far is it advanced up that bolt? 1 thread. 24 threads per inch, which means 1 inch is 24 threads, which means 1 thread is 1/24 of an inch. Correct? So if I turn it 2 turns, it's now gone 2/24 of an inch, right? Which can reduce to 1/12 of an inch. If I were to turn it 8 turns, it would be 8/24, or 1/3 of an inch. Does that make sense?
Yeah.
So I give you the number of turns, and I give you how many threads per inch. This top is just your number of turns, and the bottom is your threads per inch. No, 1/4 inch is the diameter of the bolt. It has absolutely nothing to do with the problem. So our next topic is to talk about decimals. The key to decimals is back to those place values. And rather than writing them out in words, I'm just going to write them out numerically. We have the 1s, the 10s, the 100s, the 1,000s, the 10,000s, the 100,000s, and so on. And what you notice with these place values is if we start at a place value and we move 1 spot to the right, that place value is divided by 10. From hundreds to tens, well, you divide by 10. 100 divided by 10 is 10. 10 divided by 10 is 1. So if we keep going past the end of the number, we put in a decimal point there to signify that that is the end of the whole number. As we go past it, those place values do the same thing. What's 1 divided by 10? Well, it's 1/10. 1/10 divided by 10 is 1/100th. Divided by 10 is 1/1000th. Divided by 10 again is 1/10,000th. And it continues like that. Now you might be looking at those place values thinking, they look an awful lot like fractions. Because they are. Decimals are nothing more than a short way of writing fractions with specific denominators, with denominators that are those powers of 10. So if I have a number like 0.38, that's really a short way of writing a fraction. That is really 38 hundredths. That's how you write it out just as you would say it, 38 hundredths. The way you pronounce it, you read the number 38, and then it's the place value of that last digit, is the hundredths. Now, of course, we wouldn't leave it like that as a fraction because both of those numbers can be divided by 2. So 0.38 is 19/50ths. So if I have 0.0375, what's that going to be? 375 over 10 thousandths. Tenths, hundredths, thousandths, 10 thousandths. A little trick, by the way, to double check yourself. 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in my denominator. Now, of course, both of those numbers can be divided by 5 will work. 375 divided by 5 is 75. 10,000 divided by 5 is 2,000. And they can still be divided by 25. 25 divided by, or 75 divided by 25 is 3. 2,000 divided by 25 is 80. So 3/80ths.
I guess we could have done 25 at the start.
Or you could have done 125 at the start even. Yeah. Yep, that would have done her. Either way.
Depends on how many steps you want to do.
Yeah, pretty much. So now looking at this, 4.384. Exactly. This is a mixed number. What's before the decimal point is a whole number, just like it is in a fraction. So that's going to stay 4. It's the 0.384, like you said, is 384 thousandths. Again, 3 decimal places, 1, 2, 3 zeros. Now the 384 and 1,000 can both be divided by 2. 384 divided by 2 is 192. 1,000 divided by 2 is 500. They can still be divided by, no, I'm going to put the 4 in front because if I don't, we forget it. They can still be divided by 2. 92 divided by 2 is 96. Or 192 divided by 2 is 96. 250. And the 4 is still there. Still be divided by 2. So the 4, 96 divided by 2 is 48. 250 divided by 2 is 125. And that's where we'll stop. That's it. Not so bad. Could divide it by 8 right away. Yep. So, the next step. You got it. When we add, remember when we add numbers, add or subtract, rule number 1 is we must have the same name. In decimals, that means line up the decimal points. Because remember, we can only even combine digits that have the same place value. So by lining up those decimal points, we make sure we're combining things with the same name. Second, we keep the same name. And in our decimals, that equates to bring the decimal straight down. Let's take a look at what that means. So if I have 4.28 plus 37.9, how do I set this up to add? Perfect. Perfect. I make sure I line up the decimal point. So for the second number, I just put the decimal point right below the other one, and I work my way out in both directions. I'm going to fill in this missing 0 here so that they're both in hundredths. So it's 28 hundredths and 90 hundredths. And I am adding. And now I would add just like the decimal point isn't even there. 8 and 0 is 8. 2 and 9 is 11. So 1, carry the 1. Now there's two ways I could handle this. I could just keep going and come back and move the decimal point down later. I was always taught when you cross the decimal point before you did the next column, you got to move the decimal point down. It really doesn't matter. I could do 1 and 4 is 5 plus 7 is 12, carry the 1. 1 and 3 is 4, and then I could go back and just move the decimal point straight down. Either one is fine. Decimals, it's extremely important to estimate because the decimal point is a really easy button to miss on the calculator. Because on most of your calculators, it doesn't show up until you hit the next number. So look at this. What's 4 and 38 basically should be about 42. So I know that I'm expecting an answer around 42. If I get, 383 or something, I know the decimal point didn't register. Subtraction is the same way, so I'm not going to waste your time with a whole lot. There's one example I want to show you. Nine minus 2.7438. Where's the decimal point on the 9? At the end of it. If there isn't a decimal point written, it is at the end of the number. Remember, we said the decimal point signifies the end of the whole number. So then we line up the decimal point on the 2 point. Yes. Again, we got to fill in zeros. There's 4 of them to fill in now. And just like any other subtraction, we go to subtract. We can't do it here. So we go to the next digit, we're going to have to borrow. Well, there's nothing here to borrow from, so we have to go all the way to the 9. That's an 8. This is now a 10. Well, I've got it here, but I need it still down here, so I have to borrow again. This is a 9. This is a 10. We're going to borrow again. That's a 9. That's a 10. And we keep going. Borrow again. That's a 9, and that's a 10.
Do we really have to do that? Why can't it just be 9 minus 2 and carry the rest of the decimal points?
Because you got to make up for the fact that this is more than 2. 9 minus 2 is 7. This is going to be less than 7. So 10 minus 8 is 2. 9 minus 3 is 6. 9 minus 4 is 5. 9 minus 7 is 2. Decimal point. 8 minus 2 is 6. 6.2562. Questions? Multiplying. Do we have to line up the decimal point? No, we do not. So we're going to take 3.28 times 5.7. We're going to actually completely ignore the decimal point as we multiply. 7 times 8, 56. So 6 carry the 5. 7 times 2, 14 plus 5 is 19. So 9 carry the 1. 7 times 3, 21. Plus the 1 is 22. So 2 carry the 2. And now before we move over to the 5, we're going to put a 0 in down here. I also like to put a line up here so I know that those are old carries. So now 5 times 8 is 40, so 0, carry the 4. See, I know that the 4 is the one that's the new one, not the 5. 5 times 2 is 10, plus 4 is 14, carry the 1. 5 times 3, 15 plus 1 is 16, so 6, carry the 1. 6, 9, 6, 8, 1. Where does my decimal point have to go? Between the 8 and the 6. Why? Yeah, you were taught you have to count 1, 2, 3 decimal places in the problem. 1, 2, 3 decimal places in the answer. Counting from the back for the answer.
I have a question.
Yeah.
Why is that, like, 2 times 7 with 5, why is it that you add the 5 after you multiply, not before?
Order of operations says you multiply before you add. That question comes up a lot, actually. This is hundredths and this is tenths, so of course when you multiply hundredths times tenths, you better get thousands. That's why you're counting up those decimal places. Also, think about it. This is about 3 and this is about 6. What's 3 times 6? 18. That's the only spot it makes sense to put that decimal point. 1.8696 would not make sense. 186.96 would not make any sense, would it? So that's the decimal point has to go there. So again, make sure you're doing that little estimate in your head. How do we divide by a decimal? So 78.563 divided by 3.2. You were taught to do something like that, right? Move the decimal point over. So that's 32. You move the decimal point over one spot here, so you move it over one spot here. That's 785.63. Why were we able to do that? Well, because division and fractions are kind of interchangeable. You know, that 78.563 divided by 3.2 can be written in fraction form. And as a fraction, I can multiply numerator and denominator by the same number. I want to get rid of the decimal in my denominator, so it's got one decimal place, I multiply by 10. If it had 2 decimal places, I would have multiplied by 100 on both, right? To move it 2 spots. 3 decimal places, I would multiply by 1,000. Either way, the decimal point would be moving the same number of spots in each number. So when you multiply by 10, the decimal point just moves over 1. It moves over 1 there. So this is really the same problem. It's the same fraction, I've just renamed it. And now, yeah, it's just your long division. 32 goes into 78 twice, that's 64. I'm going to fly through this part a little bit. So that's 14, bring down the 5. 32 goes into 114 4 times. It's 128 with 17 left over. Before I bring down the 6, though, I have to do what? Move up my decimal point. Move up the decimal. And I have to be very careful. 32 did not go into 7, so it stayed blank there. 32 went into 78. The 2 went above the 8 because that was the last digit I had used at that point. Now 32 goes into 176 5 times. That's 160. There's 16 left over. Bring down the 3. 32 goes into that 5 times. There's 160. There's 3 left over. Now let's say I tell you I want this answer to the nearest thousandth. What decimal place are we at right now? The hundredth. Well, I'm out of digits. How can I go any further? Add a 0. 32 goes into 30. 0 times. Now that's the thousandths place. Does that mean I'm done? No. What do I have to do? You have to add 1 more. 32 goes into 300 9 times.
So you have to keep going until it evens out.
Nope. I don't have to keep going. Now I can stop. I wanted it to the nearest thousandth. I had to go 1 digit past because when I get that 0, I don't know if that's going to stay as 0, if it's going to round down to 0, or if it's going to round up to 1. I had to go that next digit. The 9 tells me that that's actually going to round up to 24.551. So I have to know how to round that off.
What if you said, I want the answer to be to the nearest hundredth, because you have a remainder of 3.
Well, hundredth? Well, then I had to go the 1 extra digit. The 0 means it stays 0.55.
what would you write in for that extra 3?
I have to drop a 0, and I have to do the division to get that next digit. That 3 is going to be gone no matter what. You don't do remainders once you have decimals.
Okay, so if you were only asking...
If I were only asking to go to the 100th, you still have to add that 0.
Go to the 100th and stop.
Well, you still have to add a 0 and get the next place. You have to go to the one place past it.
Okay.
So I still had to get to that thousandths place, because that thousandths place tells me if that's going to stay 0.55 or if I have to round up to 0.56. This one happened to be a 0, so it would have stayed 0.55 at the 100th.
So
But if it
then-
were 5 or larger...
After you would add that 0 and it was 30 divided by 32 and you can't do it, it's 0 and you just stop.
So then you stop there and then say, okay, now, yep, that is 0.55.
You don't have to worry about it.
But you always go just one place past where you're going to round to. That's a big mistake a lot of students make too, by the way. Let's say I give you a number like 38.7248, and I ask you to round it to the nearest hundredth. Here's the hundredth place, right? That's a 4. That is 38.72. That is the correct answer. I see students that do this all the time, though. Oh, the 8 rounds that to a 5, and then the 5 rounds that to a 3. You don't double round. It's only the next digit, period. We are out of time, so I'm going to give you your homework. Page 63 to 65. 1 through 73, the odd. And page 72 to 75. 1 through 67, the odd. Thus concludes